Hello, everyone. So, we were discussing about probability distribution, and what I explained you that in numerical data, we do have two types of data. One is discrete, another is continuous. Discrete numerical data is a data which is countable, and the continuous data is not countable. It can be represented in the form of class intervals. Okay. So probability distribution is the distribution of all the possibilities of an event. Okay. Probability, which is telling you uncertainty. Okay. Or uncertainty about whom? Uncertainty but about outcome. That's what it is telling. Uncertainty. Okay. For example, tossing of a coin, you may get head or tail. So uncertainty, either of them can be you can get. So there is a 50% chances of head and tail. You can roll a dice, you may get 1, 2, 3, 4, 5, 6, any of the values. So 1 upon 6 percentage of the chance for each. Okay, 1/6 chance for each. Okay, so we can have a data distribution in form of discrete and continuous both. Okay, because we do have events in such types. For example, head and the tail, these are the two outcomes. They are discrete in nature. Similarly, this is also discrete in nature. So since our outcomes are discrete in nature, we will be following about discrete probability distribution. Okay. And when our outcomes are continuous in nature, then we will be following continuous probability distribution. Okay. There is a random variable. I also explained about the random variable, that it is defined over a function. Okay. It is defined over a function. This function can be discrete or it can be continuous. So random variable is defined over this function. It comprises of all the possible values which are the outcomes of random phenomena. That means what whatever be the possibility of outcomes, they can be given by a random variable. Okay. So in discrete, random variable may have either the result as head, either the result as tail. Random variable can give either head or either tail in case of discrete. Okay, because as per the definition, we told any numerical outcome, if I can say head as 0, tail as 1, on the basis of random phenomena. So random phenomena, how we are going to define random phenomena? It's a random function. It's a function actually. A random phenomena is a function. Okay. And random variable is defined over this function. Okay. So after performing a phenomena. After performing a function, you're going to get a result or outcome. And if that outcome is discrete in nature, you can represent the discrete values with respect to with the help of a random variable. So understand the things technically. Okay, fine. So if you want to, because now most of the people they do struggle in understanding the concepts of this random variable. Okay, so let me share my entire screen and make the things more simple for you. So you'll never forget these concepts. Okay, so here it is. I told that you are having numerical data. Numerical data can be divided into discrete and continuous. Okay, discrete, for discrete distribution, like you are having 0, 1, or you are having 1, 2, 3, 4, 5, 6, such as countable outcomes. Continuous don't have countable outcomes. They represent between intervals. For example, 1 to 10. Okay, values between 1 to 10. So it can be like 2.7, 3.8, 4.9, anything between 1 to 10. So this is continuous. Okay, so we do have events, we do have actions which performs, okay, which performs and produces output. If these outputs are discrete in nature, then okay, one more thing, these events, actions, and the production of output is random, they are uncertain. Okay, they are uncertain. So 0 can also appear, 1 can also appear. So for random outputs, for such actions or events which are performed, we have discrete probability distribution. Okay, discrete probability distribution. Okay, and for storing those outcomes, we do have a random variable. So random variable is a variable which can achieve any value in a distribution. If it is discrete distribution, so that will be called as a discrete random variable. It is a continuous distribution, then it is called as continuous random variable. So random variable is to hold a value. If discrete distributions, it will hold discrete values. If continuous, then it will hold the continuous values. Okay, fine. So this is probability distribution. All right, for discrete and continuous. Okay, we are having uniform distribution, binomial distribution, Poisson distribution, Bernoulli distribution. All these are discrete probability distributions. Okay, so in discrete probability distribution, we do have discrete random variables. Okay, and they provide the probabilities of each possible outcome. Okay, for example, binomial Bernoulli. Before that, there are certain characteristics of discrete. The sum of probability of all the outcomes is equal to 1. That's what I told now. For head and tail, the probability is 50%, 50% for both. So the sum is equal to 1. For rolling of a die, the probability of each number is 1 by 6. So if I add 1 by 6 6 times, I'm going to get 6 by 6, that is 1. Still 1. So in case of discrete probability distribution, the sum of the probabilities of all possible outcomes is equal to 1. And probability, we very well know, it lies between 0 and 1. So there is no, okay, no further discussion is required based upon it. ये तो property, it's a property of probability, 0 to 1. Okay, fine. Then Bernoulli distribution as one of the type of discrete probability. Okay, Bernoulli distribution as one of the type of the discrete probability distribution gives you binary outcomes. Okay, only two possible outcomes. That is either success or either failure. If you represent success by 1 or p, failure will be 0 or 1 minus p. So obviously, no, discrete 0 or 1 is discrete. So this is Bernoulli probability distribution coming under discrete. And the function which defines Bernoulli distribution is is okay, given as p x equal to 1, where x is a random variable, 1 is a value which a random variable got, and p is the probability. And if x equal to 0, then q is the probability. So this is probability mass function, remember, PMF. So for discrete, we do have PMF. Remember, the functions over which events are described, they are probability mass functions if we are talking about discrete distribution. And if you will talk about continuous, then they will be PDF, probability density function, that I will teach you ahead. Okay, so I am having PMF, probability mass function. So for every discrete distribution, we will be having PMF. Okay, so this function PMF is giving two values, P and Q. When the outcome of a function is 1 defined by random variable, then we say that okay, probability is P. When x equal to 0, random variable 0, then the probability is Q, and Q is equal to 1 minus P. This is the relationship. So this is probability mass function for Bernoulli binary outcomes. We do have binomial distribution also. Okay, where the number of success in a fixed number of independent Bernoulli tries, it represents the number of success. That means Bernoulli we did for one time. In this one time event, you may get success, you may get failure. But when we repeatedly doing this activity or event, then it gets converted into binomial. So Bernoulli will be converted into binomial if we do a task with given number of times, number of trials. For example, you are tossing a coin 10 times. This is binomial. If you tossed a coin, this is Bernoulli. So people get confused between Bernoulli and binomial also. Now I hope you are listening to me sincerely. So the difference is clear. So if you are doing n trials, that means you are tossing, or if you are rolling a dice 10 times, n equal to 10. And p is the successive. That is same with like Bernoulli. No? Success is p for Bernoulli also. Failure is q. So here, with respect to binomial distribution, you can write like this: Px equal to k. X equal to k means number of times success came. So you rolled, or you tossed a coin. For example, you tossed the coin for 10 times, and you are saying that head is my success. Okay, you have to define your success also. You are saying that head is my success, and 6 times head came. Okay, 6 times head came. Okay, so you can write like this according to binomial: 10 C6. I hope you know about NCR combination. In 11th standard in maths, we have studied. If I do talk about Indian maths criteria for schools, NCR combination. We are having NPR permutation. So permutation and combination. This is what we studied in our maths. So it's NCR, means out of 10, 6 times I got success. Dot. This is the probability of success. How many times? 6 times. Dot. This is failure. How many times? 4 times. And we know what is the probability for tossing of a coin. For head, 50%. For tail is also 50%. So we will know about this thing. So value of p will be 1 by 2. So the answer will be 10c6 1 by 2 to the power 6, 1 minus 1 by 2 to the power 4. Ultimately, it will be 1 by 2 to the power 4. So after solving, you will get the result. And the formula for NCR is n factorial upon n minus r factorial into r factorial. This is the formula for combination. Okay, so this is binomial distribution. We are having Poisson distribution also. That means models the number of events occurring in a fixed interval of time. Now remember, fixed interval of time. Here time factor is added. Previously in binomial Bernoulli, we are doing the event anytime. So time was not a matter. But if you are including time of event, so for that you have to apply Poisson distribution, not binomially, not binomial, not Bernoulli. No, Poisson distribution is what you have to apply. Okay, so this is the formula for binomial: e की power minus lambda, lambda की power k divided by k factorial, where lambda is the rate of occurrence, average rate of occurrence. Okay, so the question can be like, in Poisson distribution, that on an average on an average, this much number of customers do visit to the shop, then how much number of customer will be visiting the shop from 12 noon to 1 p.m. Okay, from 12 noon to 1 p.m., how many customers are going to visit the shop? So here time you have mentioned 1 hour, 1 hour slot. In this 1 hour, on an average, how many customers are going to visit? So we can apply Poisson distribution. Okay. So lambda is the average rate of occurrence. That means they have already given on an average how many customer appear. They have given. Now K is your time period. That means okay, for 1 hour, for this much 12 noon to 1 p.m., how much customer may appear. So this we can put in the formula. So this is whenever you are when you are whenever in a question you have been given that okay, according to the time limit, fixed time interval, you have to answer, then apply Poisson. When time is not given, then Bernoulli or binomial depend upon you. Now you understood what is the difference between them. Okay, we are having geometrical distribution also, so not that much important. But if you want, let me tell you, it represents the number of Bernoulli trials needed to obtain the first success. Okay, that means you are trying, keep on trying an event, and you will only stop when you will be successful. Okay, that means you tossed a coin, you got tail, toss the coin, tail. Your aim is to get head. Unless and until you will not get head, you will continue tossing the coin. And once you got the head, now it's okay. Stop. So probability of success in each trial is P, and you are going to perform number of Bernoulli trials needed to obtain the first success. So this is what your success is. Okay, so 1 minus P. That means 1 minus P means okay. P is the success now. P is the success. So and that is head. So you got tail at the first time, tail at the second time, tail at the third time, tail at the fourth time. So that's all 1 minus P. How many times you got that? Okay, 4 times I got failure. After that, I got success. So 1 minus P into the power 4 dot P. This is geometrical distribution. Geometric distribution. Okay. Okay. Hypergeometric not required at the moment. Okay. So in every probability distribution, what you have seen, we are having discrete outcomes.
Sorry, sir.
Yes, please say.
Can you go back to Bernoulli again and
Hmm.
quickly explain? Sorry.
Hmm. Which one? Point?
Bernoulli, the first one, Bernoulli,
Bernoulli.
and the
Yeah.
yes, sorry.
See, Bernoulli, we are having only two possible outcomes. Okay. Success or failure. Only two possible outcomes in Bernoulli.
Okay.
Okay. We are doing an event that is having only two possibilities. That's what happens in Bernoulli. In binomial, It's like Bernoulli only, but we are doing this event not for one time, multiple times.
And number of times. Okay.
Okay, multiple times. Then it is binomial. And if there is a time constraint, then it is Poisson. Formula is also changed. Here the formulas are very easy, like P and Q. Here it is NCR P key power R Q key power n minus R. This is binomial. In Poisson, the formula is changed. E key power, okay, you can check out the formula, like E key power lambda key power K. Okay, so it's something like this: E key power lambda key power K upon K factorial. This is Poisson distribution. Then we are having geometrical distribution also. That means we are keep on trying unless and until we will not get the success. Just keep on going. So if we got success at the first instant only, so answer is P. If we got the success in the second attempt, so first attempt you got failure, Q, then P. If you got success in third attempt, so Q, Q, P. If you got success after three attempts, at the fourth attempt you got the success, so Q, 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 and then P. That means three times you got failed, and after that, so you are keep on doing, you keep on trying unless and until you got haven't got the success. So this is geometrical. Okay, geometrical distribution. Okay, fine. All right, so that's very simple and discrete. Okay, we are having, okay, there are certain more things. Okay, standard deviation, variance also uh, know. Okay, but there is one thing that is expected that I will teach you ahead. Okay, not at the moment. Now, what about continuous probability distribution? Now, continuous is very much important because in most of the cases we do have continuous probability distribution. Okay, most of the cases. So, hmm, there's one more thing, that is uniform distribution. Its definition is given: uniform distribution is a type of probability distribution where every possible outcome is equally likely. Okay, equally likely. That means each value within the range of the distribution has equal probability of occurrence. Okay, equal probability of occurrence. That is uniform distribution, equally likely. So it will be like this. Okay, this could be the plot of uniform distribution. That means whatever be the values which are present here, they are equally likely to be present in form of outcome. Every value is having equal chance, equally likely. So uniform distribution. Okay, fine. It's uniform in nature. All right. Now, so uniform distribution is characterized by a constant probability for all outcomes within a specific range. Okay. So uniform distribution is characterized by a constant probability for all the outcomes. It's constant for all the outcomes. The probability is constant within a specific range. Within a specific, there will be a range. Okay. So like this. Okay, like this. So from A to B, from A to B, they are defined by a function like this: 1 upon B minus A, and less than A or greater than B, it is 0. So I'll explain you. Okay, I just explain you. Let me tell more about this uniform. Okay, wait a minute. Continuous probability distribution. Okay, and we did mention this uniform. I guess it's been written here. It came here in discrete, like uniform and all these. Okay, fine. But let me talk more about it here, from here. So discrete you have seen, continuous probability distribution. Now I'm explaining you. So things are like, when your data outcomes are continuous in nature, then you can apply continuous probability distribution over it. Okay. Age, for example, age is one of the feature which you can represent in form of continuous probability distribution. Age. Okay, fine. So we can represent age in between the intervals. So any value which can be represented in an interval, that will be continuous in nature. For example, normal distribution and student t distribution are famous continuous probability distributions, in which normal distribution is our reference distribution. Normal distribution is reference distribution for us. Okay, we do, if there is a numerical continuous feature, we do expect we do expect that it should be normally distributed. I already told you what normal is. Normal or Gaussian, it's all same. That means symmetry. So normal distribution is very famous continuous distribution. What is student t? I will let you know ahead. Okay. So uniform distribution, discrete uniform distribution. Okay, because this word came above na, uniform. So uniform means every outcome has same probability. For example, tossing of a coin, head and tail, same possibility, point 0.5, point 0.5. Rolling of a dice, same probability, 1 by 6 for all. 1, 2, 3, 4, 5. These are the outcomes. Every outcome is having same probability, 0.16667. That is 1 by 6 only. Binomial, I explained. Bernoulli, I explained. Poison, I explained. But here is one example related to the poison which I was explaining. In a shop, 8 customer arrive between 12 p.m. to 1 p.m. I need to find the probability of arriving 3 people between 12 to 1. So this is on an average. 8 people arrive between this time. On an average, this much people arrive between 12 p.m. to 1 p.m. on a shop. What is the probability of arriving 3 people between 12 to 1? For this, you can apply Poisson. Okay, it's not binomial, it's not Bernoulli, because here time is mentioned. So for time, you have to apply Poisson distribution. It is discrete, okay, remember, because number of customer can't be in a fraction. There is no number of customer like 3.5. No. Okay. So number of customers are like in discrete values only. Fine. Probability of having probabilities like your between 0 to 1. Okay, so that can be in a fraction. So here, uh, lambda is the average number of customer who do appear between 12 to 1, and we want 3. Okay, 3, x equal to 3, that between 12 to 1, what is the chance that 3 customer are going to appear? So 8 ki power 3, then epsilon ki power minus lambda. So epsilon, sorry, minus lambda, that is minus 8, divided by 3 ka factorial. Epsilon value is 2.71. You can put it here, you can get the value. Answer is 0.0287. Okay, fine. So this is Poisson. So we can have a discrete uniform distribution. Okay. Binomial Bernoulli Poisson. Geometric I explained. Okay, and continuous, as an introduction I told that you are having class interval values. For example, age. Okay. Now, one more thing. Here, in continuous distribution, I told that it is very much important because most of the real world problems are continuous in nature. If you do talk about signals, they are continuous in nature. Okay, we can have discrete, we can have continuous, but okay, for example, now you are having voltages. Okay, we can have discrete also. Okay, but mostly now we are having continuous data. Okay, fine. And we do expect the data should be in a continuous distribution because in discrete we are having limited values. That is the issue. In discrete we are having limited value. For example, 0 or 1. So with this limited value, we can create limited options, yeah, limited opportunities. But when we are having continuous distribution, we can perform interpolation to create new opportunities. That is why continuous distribution is important. Interpolation, we can have different types of interpolation: binary, bilinear interpolation. Okay, linear interpolation. Okay, that means identification of intermediate values. For example, A and B, these are the points. P1, P2, these are the intermediate points. You can find. So interpolation means from known points you can identify unknown points. That is called as interpolation. Very important concept in numerical method, numerical it's like numerical maths, and in our engineering we have studied these things in M3. There was a subject called as engineering mathematics 3. So in numerical analysis, this interpolation is very much important. So identification of new points, that is called as interpolation. Okay, and when we get a new points, we are not limited. We have much more opportunities to create new set of data. That's why continuous distribution is important. So since you are studying ML in deep learning generative AI, this continuous keeps very important because okay, we want to create a new data now, so continuous distribution is preferred there. With discrete we are having limited options. Okay, because discrete is countable, so we can have a counting of 2, 3, 4, 5, 6, 7. Okay, just the limited number of numbers. But in continuous, we don't. We have to represent data in interval. Okay, so we don't have any limit related to it. Fine. That's why continuous is important. Okay, and in continuous, we do have function that is called as PDF, probability density function. In discrete, you have seen PMF, probability mass function, but here we are having density function, probability density function. Here also I am having a random variable x, and it is also defined over this function. It may take any value between, okay, between a range of values. It can take any value which are defined by this function, which are defined under this function. It can take any value which are defined inside this function. Okay, over which this function is defined. It can take any value from them, and it will produce an output. Obviously, probability, because we are getting probabilistic output only. Okay, fine. So they told here that in continuous distribution we are having one of the famous distribution as Gaussian distribution. One of the famous Gaussian or normal. This is one of the famous distribution, and I multiple times told you why it is famous, because of symmetry. Okay, because of symmetry. Mean, median, mode all are equal. Okay, mean also, median also, mode also, all are equal. Okay, and the formula for normal distribution is 1 upon square root of 2 pi sigma e की power minus x minus nu का whole square divided by 2 sigma square. Okay, this is formula for normal या Gaussian distribution. Okay, where nu and sigma are mean and standard deviation. Mean and standard deviation. Standard deviation. Okay, fine. And I guess we are having one more thing, that is standard normal distribution. Standard. Yeah, uniform normal distribution. Uniform, not standard, it's uniform normal distribution, which is having like a unit variance, or I think variance is okay, unit variance. It is having unit variance like this, and with deviation equal to 0. We'll recheck it. Okay, these are the properties. So it's uniform, standard normal, yeah, uniform normal distribution. There are certain properties we'll study here. Okay, so this is our reference plot for continuous distribution. We are having as an example Gaussian and normal, and it will behave as a reference for us. So whenever we are having a continuous distribution, we do expect that data should be normally distributed, yeah, Gaussian distributed. Okay, so I am having the complete notes for that normal distribution. It is also known as Gaussian, so please don't get confused. Normal and Gaussian both are same. It's the same name. Bell curve, continuous probability distribution, symmetrical around mean, which represents its center or the average value. Bell shaped curve, it is widely used in various fields. I already told you that why it is important. Statistics, finance, science, engineering. Because mostly na, in these fields you are getting a continuous data, not discrete data. Discrete is limited, but the scope of continuous is more. It's high scope. Okay, so properties I already told. Symmetry, bell shape, left and right all are same. Mean, median, mode, they are also same. Okay, they are also equal and located at the center of the distribution. I also marked in my diagram, also I marked. And it follows an empirical formula of 68, 95, 99.7. This is the empirical formula of normal. In normal distribution, approximately 68% of the data falls within one standard deviation of the mean. 95% falls within two standard deviation, and 99.7% falls in three standard deviation. What these standard deviation means? Okay, it's saying that 68% of the data falls in one standard deviation, that is sigma. Then 95% falls in two standard deviation, 2 sigma, and 99.7% falls in 3 sigma, 3 standard deviation. Okay, sigma, 2 sigma, and 3 sigma. Okay, so what these are, I will let you know ahead what this sigma, 2 sigma, and 3 sigma means. Okay, about the data distribution. It will be like, okay, if I make it here, okay, it will be like this. Okay, it will be like this. All right. So this is the shaded portion. I'll let you know about this thing. Okay, that's sigma. Okay, 2 sigma. Okay, what it is. Fine. So right now there is empirical formula: 68%, 95%, and 99.7%. This was data falls in the standard deviation 1, 2, and 3. Okay, fine. And this was the normal distribution, standard normal distribution. Okay, so in standard normal distribution, okay, standard normal distribution. Okay, here, let me correct the words because I told you that we will cross check. Mean is 0, and standard deviation is 1. Okay, we actually make standard deviation 0, mean as 1, so we have to recheck because above I told now. Here, I think in one of the sheet I told, just here. So just correct it. Okay, here I told. So, okay, I told about the variance. No, no, I was correct absolutely. So variance is standard deviation only, na? You haven't interrupted me at the same time. I was correct. Variance is 1. That means standard deviation is also 1. Mean is 0. Okay, mean is 0. Standard deviation is 1. Okay, fine. So I was correct, but when I told variance equal to 1 and wrote sigma equal to 0, you should have interrupted me. Sir, variance and standard deviation are same only. So both are 1. Mean is 0. All right, fine. This is your standard normal distribution. Okay, fine. So here the applications of standard your normal distribution, the application of standard distribution or normal distribution, as I told that we do use in various mathematical and engineering and finance and many applications or the areas. Some of them are: first is the statistical inference. The statistical inferencing, that means many statistical methods such as hypothesis testing, confidence interval. That means in statistical analysis, we do use normal distribution. In manufacturing also, the normal distribution is used. Okay, in finance also, stock prices prediction and all these things, normal distribution is used. In biological sciences also, we do use the normal distribution, such as height is normal, weight is normal, age is normal. Okay, and biological and other many things are, we are having normal distribution. So as I already told that in most of the cases we have normal distribution, yeah, Gaussian distribution present. Okay, and this is the diagram I already made multiple times. Okay, mean, median, mode are equal, and this is normal distribution. Okay, fine. This is the formula. Okay, fine. This is the formula I have written multiple times. Okay, and standard deviation 1, mean 0. This is standard normal deviation. Okay, this is standard normal distribution. Okay, fine. So here it is. There is one example also given for the normal distribution. That means, imagine you are a teacher and you are grading a class of students on a difficult exam. Okay, let's say the mean score of the on the exam is 75 and the standard deviation is 10. So this means that most of the students are likely to score around 75. Some are scoring higher than 75 and some are scoring lower than the 75. Okay, so the mean score is 75 and the deviation is 10. Okay, mean is 75, deviation is 10. So obviously we are having 75 plus minus 10. Okay, 75 plus minus 10. Okay, so we can have 85 also, we can have 65 also. Something we can have. Okay, something we can have. All right. So if you want to plot the distribution of this graph, where the x-axis will represent the scores and y-axis represent the frequency of these scores, that how many times they are appearing. So it will be like a bell shape only. Okay, it will be having bell shape only, and the peak will be 75. Okay, and when you move from this mean in either of the direction, the frequency of score will decrease symmetrically. Okay, so at the top we are having 75. Okay, this will be 75, and if you go here or if you go here, obviously it will go down. So the most students will cluster around the mean 75, and few students will be scoring high, few students will be scoring low. So normal distribution will help in understanding the likelihood of different outcomes and widely used in stats, economics, and many other fields. Okay, that's what normal distribution means. Okay, fine. Then we are having student T distribution also. Okay, so what this student T distribution is about? It is same like normal distribution only. Student T is also same as normal distribution. Okay, that means it looks like same like normal. Okay, however, there is some story behind student T. Okay, I will explain you. See, the student T distribution is simply T distribution, also called as T distribution. Is a probability distribution used for statistical inference. It is similar to normal but having heavier tails. Make it more robust for small sample size. Remember one thing. Now you have to remember one thing. See, we are having two types of distributions in general for continuous. One is normal, one is student T. Student T or T. Both of them looks like same only. This is normal, and this might be your T distribution, which are having heavy tails. Okay. The difference is in terms of structure, I told heavy tails. This is the difference. Okay. So normal, the peak will be a bit more. In normal peak will be a bit more. While in case of student T, the tail will be more. Okay, the tail will be more. Heavier tails. Okay, fine. And student T is used with small data. Remember, student T distribution is applied over small data, while normal distribution is applied over huge data. Okay, fine. It's applied over huge data. Fine. So that is the difference between normal and the student T distribution. Both looks the same, but normal is applied over huge data. Student T is applied over small data. That is the difference. Student T is having huge tail, normal is not having that heavier tails. Okay, fine. That's the difference. T distribution is applied commonly in hypothesis testing and confidence interval. We'll study at hypothesis testing what it is. Hypothesis testing is for proving a statement. Proving a statement. Where this is where the hypothesis testing is applied. Okay, fine. This is where hypothesis testing is applied. Okay, fine. So this is student T. There are many things related to student T also. Okay, like shape, I told. Okay, shape is like normal only, but it is having one thing: degree of freedom. Degree of freedom. Okay, and heavy tails. Okay, suitable for small data, small sample size data. It's like it's symmetrical only. Like normal, it is symmetrical. Okay, there is one new term came here: degree of freedom. Okay, again, it requires some amount of time to explain degree of freedom. Okay, before that, I will be talking about probability density function. Then I will talk about the degree of freedom. Okay, just give me some time related to it. Actually, student T was proposed by Mr. William because there was a restriction at his working place to publish the research papers, research articles. So instead of his original name, he used a pseudonym, student. Actually, he can't give his name like William distribution. He can't give this thing. So he was a student there. Okay, and because he was a student, he can't publish the research article with his name. So he gave his article with the name student distribution, not using his name. Okay, so the distribution is supposed to find the best sample from a small sample. Okay, so that's what it is proposed for: small sample of the data, best sample out of small sample. That is a student T distribution. Here is the diagram. You can see blue one is your normal distribution. This is normal. Okay, this is normal. However, these are the heavier tails. This is heavy tail. Okay, it is not touching. It is not touching the grounds. Okay, for student T, it is not touching the ground. They are heavy. However, in case of normal, you can see it's touching the ground. Blue is touching the ground. Okay, but orange is not touching the ground. That's why it's called as a heavy tail. So these are heavy tails for the student T distribution. Okay, fine. So this image shows the comparison of two distributions. Student T is fatter than normal. The tail is fatter than the normal. Okay, fine. So that's the difference. Okay, fine. And the shape of the distribution depends upon degree of freedom, which determine the sample size. I will tell you about this thing, degree of freedom, what it is. Okay, so there are few things which we have to recall related to this continue. So all these things now I just mentioned. Degree of freedom means the number of independent piece of information. Okay, that means degree of freedom is independence. Okay, independence. Okay, that will define the shape. Now what this independence is, what rest of the things are, will cover. However, what I taught in this session is related to discrete, different types of discrete and continuous distribution. Discrete you understood: Bernoulli, binomial, Poisson, geometric, uniform discrete distribution. All you understood. In case of continuous, our target is normal distribution. And the probability density function for normal, that is the formula which I gave. Okay, this is the formula for your normal distribution. Okay, and this is probability density function. This is what we call as PDF. The properties of normal I already told. And why this is having a significance? Because in most of the real world applications, we are having normal distribution data. Okay, and it follows a rule: sigma, 2 sigma, 3 sigma. This kind of rule it follows. That means 68%, 95%, and 97%. Okay, so it's like this. Okay, like this. Here I'm dividing the data. Okay, here I'm dividing the data. So it takes the value, like if I, this is the mean, median, and mode. Okay, mean, median, mode, that is the central value. Okay, fine. So this can be like, okay, this can be like 68% of the data. Okay, this can be like 68% of the data. Okay, and then if we add one more part, then it will be 95%. So something like the sigma 2 sigma 3 sigma rule is there according to the distribution. Okay, and then student t was there. Okay, for small sample of data, small sample. So this is for normal is for big data, huge samples, huge, and these are for small sample, student t. They're effective, and it is having degree of freedom and few more things, and its formula is having gamma function. Its formula is having gamma function that I will talk about it ahead. Okay, so these are something related to probability distributions, very important, and these terms are right now I'm covering all these topics under statistics. Okay, but they are put up again in probability. These topics I'm covering in statistics, but they are covered in probability also. All right, fine. So that's the case. Okay, or either this. Okay, let me tell you one more thing. Either this 3 sigma can be like this, 2 sigma, 3 sigma, it can be like this. Okay, mention that 90. Okay, like this. I will confirm this part of the rule. Okay, this is the shaded region. Most of the area, most of the data points are present here. Small parts are present here. Small region. Okay, so I will confirm that how you are going to add it, the sigma values. Okay, so in statistics we are studying these topics, but they will be repeated again in probability ahead, because right now we are talking about statistical inference. So all these things now are used in statistical inference. So that's why I put the topics here only. Okay, fine.